Alright, hello everyone, my name is Malik, and here I'm going to show you guys how to do problem number 23 for resistivity and resistance textbook. So the problem reads, when 115 volts is applied across a wire that is 10 meters long and has a 0.30 millimeter radius, the magnitude of the current density is 1.4 times 10 to the 8th amperes per square meter. So you have to find the resistivity of the wire. Okay, so first you want to write down our given values. So our first given value is the voltage. So you have V here equaling 115 volts. Next we have the radius, lowercase r, which equals 0.30 millimeters, or 0.3 times 10 to the negative 3 meters. I'm going to convert to SI units. Next we have the wire length. So the wire length is going to be equal 10 meters. Then we have the current density, or J. So you have current density, J, which equals 1.4 times 10 to the 8th amperes per meter squared. Alright, so we got our given values. So on the path to finding the resistivity of the wire, we first want to find the resistance. In order to find the resistance, we have to find the current. So the equation for current is I, which equals J times A, or the current density times the area. And we know the formula for area equals pi r squared. So from there, our equation would be I equals 1.4 times 10 to the 8th times pi times 0.3 times 10 to the negative 3 squared. So then just put this into our calculator. 1.4 is 10 to the 8th times pi times 3 is 10 to the negative 3 squared. And then from there we get our current, which is 39.58 amperes. Okay, so now we got our current. So now we want to find the resistance. So the equation for resistance is R equals the voltage divided by the current. So we already know the voltage was 115 volts. So all I have to do is an R, which equals 115 divided by our answer here, 39.58. Our resistance equal so resistance will equal 2.90 ohms. Alright, so we got our resistance. So now we want to find the final part of the question, the resistivity. So we know that the equation for resistivity equals P equals the resistance times the area divided by the length. Okay, so from here we have our resistance already, so that's going to be 2.90 ohms times pi times 0.3 times 10 to the negative 3 squared over 10. And what do we get? That, and we divide by 10. Alright, so we get our resistivity, which equals 8.21 times 10 to the negative 8 ohms per meter. There we go.